Hey everybody, so today I'm working on my electric log splitter. This is I bought this several years ago at Home Depot. It's a Homelight brand log splitter. It's a little thing. I really like this thing. It's got a lot of use. It doesn't have capacity to do really huge logs, but that's fine because most of the logs that we cut are pretty short because I have a pretty small Vermont Castings Intrepid stove. And even though it's a small stove, it throws a lot of heat, so we use it a lot in the wintertime. We pretty much light it just about every day during the winter cold months. But the other day, my son was out here using it. The other thing too is it's a really safe model. You actually have to press this button with one hand to start the motor, which runs the hydraulics. And this won't actuate until you pull this lever over here, which is behind this guard. So you can't like set it and just let it start going. As soon as you take your finger off of the lever, your hand off the lever or your finger off of this, it's going to stop and actually retract. So it's safe. So I've been able to let the kids use this to split wood for quite a few years now. And I don't know, Aiden's sitting right here with me now. How old were you when I first let you use this, Aiden, do you think? 2? Anyways. So he was using it the other day and it just stopped working. Naturally, the assumption would be that he broke it because he usually breaks stuff to get out of doing work, right? Right. So here's what it does. If you press the button, all the motor does is hum and won't start. And if you keep doing it, it'll die. You'll hear a click. And then I don't know if you heard that or not, but there was another snap. What that is there's a thermal protection overload built into this. What that does is it senses that the motor is getting very hot somewhere, and probably on the armature itself or the windings, and it automatically opens and cuts the electrical circuit to the motor winding. And then in a couple of seconds it cools down enough and it auto resets and the contacts close again. So that's why it'll work again. Now just then it almost started. So I took this cover off so I could get to the fan because that makes it really easy to get to the shaft. So the first thing you want to do in diagnosing this kind of a problem is to see whether or not the problem is something with what the motor is driving that can't turn, like if the pump was damaged and jammed or something was wrong outside the motor itself, but you know, the work that the motor is supposed to do, whatever it's attached to, could that be the problem? So one of the easiest things to do is to just be able to get to the shaft and with no power applied, try and rotate the shaft and check and make sure it rotates freely. And this spins no problem. So that tells me a few things. It tells me it's not the bearings in the motor and it's not the pump that the motor's hooked up to. So the next thing I want to do is I want to see whether or not maybe the problem just has something to do with the start circuit. It's a good idea if you know what the direction of rotation is supposed to be on the motor ahead of time. The reason why is because if you have a motor that has a start circuit problem, if you energize it and you give it a spin, it may very well start rotating, but it will rotate, it'll start and continue to run in whatever direction you spun it. In other words, if I press this button and I do this and it starts, it'll run in that direction. But if I press this button and I do this and it starts, it will run in that direction. And in some applications that could be very bad. I don't know what would happen to this hydraulic pump if we ran it in the wrong direction. I don't really want to find out. So it would be good if I knew what direction this is supposed to normally rotate in. And one of the clues would be if I hit it, it moves a very slight amount. If I rotate it to the right position, see, it wants to go that way. That way it didn't go anywhere. See, it wants to go that way. All right, so that's generally the direction it wants to go in, is looking at it from the back clockwise. So I'm going to wait for it to reset. Now it's reset. So what I'm going to do now is I'm going to give this a spin and press this. So I'm going to mechanically substitute for that motion that's created by the start circuit. just going to let it run for a second and make sure that that sounds okay and everything else is okay. Perfect, right? No problem. But if I let it come all the way back down to a stop and I try it, back to the same problem. So now I know that the problem is something to do with the start circuit. It's either the start winding is bad, or there should be a start capacitor involved maybe. That could be bad. I don't know whether or not this has a centrifugal switch that's involved. It doesn't sound like it does. So I think this is more like a kind of like the way the bench grinder, any of you guys who followed my series on the Hammond bench grinder that I rebuilt, that has no centrifugal switches in it, but it does have a capacitor responsible for starting the motor. So that capacitor is most likely going to be inside this box right here. So I have to caution everyone at this point. Obviously, this is an electrical shock hazard once you open this up. I am going to unplug it. That's a whopper. Okay, I can tell just from the odor that something has fried in here. And actually, if I look at this device right here is the capacitor. If you look at the bottom of it, you see how this is all bulged out? This thing is kaput. All right, so there's our whole problem right there. We need to replace this device, and there's a very good possibility that once we replace this device, this will be all set. All right, so when it comes to these types of capacitors, we're concerned with two ratings. We're concerned with the capacitance, which is the standard measure for capacitance is a unit called farads. But farads are a very big unit as far as capacitors go, so typically you'll find capacitors are either in microfarads or picofarads. This right here, 60, with this little Greek symbol for micro, and this large F means 60 microfarad. So that's the capacitance of this capacitor. It is a 60 microfarad capacitor. Has a tolerance or plus or minus 5%, which means that if we were to measure the capacitance of this capacitor and it was good, it would have to be no more than 63 microfarads and no less than 57 microfarads, right? Because 5% of 60 is 3 microfarads. So plus or minus 3 is 63 or 57. And then 50 to 60 hertz, that means that this is an AC capacitor. And here's the second important bit of information right here. 300 volt AC. That is the maximum working voltage of the capacitor. Notice I said maximum. So the question is, well, wait a minute. This is a 120 volt device. Why did they put a 300 volt capacitor in there? Simple. It's overrated intentionally to make it be able to handle the work that's going on here, because you've got these surges that are developed starting and stopping, a lot of stuff going on. So sure, I could put a 150 volt AC capacitor in here, but it would probably have a much shorter lifespan. So that being said, we are going to try and source a capacitor. So what do I have to take into consideration when I'm replacing this capacitor? Well, a couple of things. First off, I want to be as close to the 60 microfarad rating as possible. The capacitance, I really don't want to mess around with that too much. Second of all, the voltage. Lower than 300 volts, if I go too far below 300 volts, the thing won't last at all. It'll fail very quickly. I can go higher, so I could put a 450 volt AC capacitor in here, and that just means that capacitor can handle up to 450 volts. That capacitor will work even better. It'll last even longer. It'll be even more stout. The problem is when you start getting into the higher voltage capacitors and the higher capacitance capacitors for that matter, the physical size of the capacitor gets larger. This is already a pretty big can, and you can see this just fits in here. Now it could be we might even be able to find one with the same exact rating as this that has a physical size smaller than this. I don't know yet. But we've got to have something that's going to comfortably fit in this case and do the job electrically. Alright, so I went and checked my pile of junk motors and pulled some caps out randomly, and you know, I found some even smaller than this as far as microfarads go. This one's a 35 microfarad, so at first this was the largest one I could find. Working voltage is plenty large enough. It's 370 volts AC. It's actually even bigger than the one I took out, or I'm taking out, because this one is 300. So this is an older one. It got wet, but this is a sealed unit, so it should still be okay. Then we found this big sucker here. This one's 50 microfarad, so it's 10 microfarad lower. Not too, you know, not too bad. I bet you this would work. Then we found this mystery cap. Came out of a pretty good sized motor, 230 volt motor. So working voltage definitely I would imagine would be okay. But for some reason I can't find any markings of how many microfarad this is. My theory is that it was silk screened on here and it came off and I can't see anything. There's, on the back here it just has the maker, the manufacturer, and talks about the chemicals that are in it, and that it's made in the USA, which would make this a pretty good quality capacitor. So I'm tempted to see whether or not that would work in there. So the first problem I have is that this is a capacitor that's permanently wired. It's got the wiring harness comes with it permanently. It's molded into there, as opposed to these all have spade lugs, 1/4 inch spade lugs, which are pretty standard. So I can either undo these screws and take this off and throw this away with the wires, but then I'm going to have to just find some wires to add onto here with spade lugs on them. I mean, with female clips that will clip on here. So I think what I'm going to do instead is I'm going to use this wire. So what we'll do is we'll strip these two wires. Now you notice there's a red and a blue, and you might think, well, okay, is there some sort of polarity? No, polarity is only with DC capacitors and DC circuits. So even though this is red, it does not denote plus, and this does not denote minus. If it was red and black, it would even look more like that was the case, but it still wouldn't mean anything. There's no reason we can't hook these wires up. Either way, these wires will work fine. I like these Klein strippers. I just got these at the last Tractor Show flea market. They're really good quality. And I'm just going to give it a little twist to keep the little strands from trying to separate when I go to stick them into the holes on the spade. Oh, see, I didn't do that one very well either. Trust me, it's not the tool, it's the operator. All right. Well, let's see what I got for 1/4 inch. Now the ones that were on that go to this normally would be 90-degree ones, so hopefully I have some of those. If not, I'm going to just try and get by with regular ones. All right, so I didn't have any of these 90-degree spade lugs that I wanted to use, so I sent Aiden back to the pile of junk motors where we got these capacitors and just had him cut some of the wires. So these already have the lugs that we want to use on the end of them. So I stripped the end of the wires. I just got to take these two wires out of the terminal block in here and put the new wires into place. Did you see some morons been doing hole shots down over there?
What's that?
You don't know what a hole shot is?
No.
Maybe they call it something else. Burnout?
No.
Spinning the tires on the road to make big black marks and a lot of smoke.
At Dale's? No.
No. In front of...
There was a whole bunch of tire marks on the road before.
There's 2 sets, but there was only 1 set. And then, I don't know how many days later, there was another set, which means, by the looks of it, the moron who did it the first time came back, like the next day or whenever, and did it again. Okay, so we got those on. So...
Yeah, I think that one first.
Well, I mean, just for giggles, let's try the smallest one first, which is this 35, just to see what it does. And I'd be willing to bet that it might start it, but it'll probably be slow. I'll just leave it like that.
Plugs right there.
Yep. Plug this in. Actually works. So there's a little, you know. Not bad though. Not bad at all.
Next one.
All right, so I'm gonna unplug it for safety because I'm a chicken. I'm even gonna discharge this capacitor, even though there's no charge in it. So let's put the 50 on, which is closer to what was in there, and see how that acts. You go ahead, you can. About the same, right?
Yeah. A little lag in the beginning.
Yeah, they all have. There's going to be, none of these are going to be instantaneous start. You know?
Let's try this mystery one.
The mystery one? The mystery one. The mystery one's made in the USA. It should be actually the best quality one. I think that last one was assembled in Mexico.
Yeah, people who don't get paid for this.
They get paid.
Not well.
You been to Mexico? That's your expertise? Go ahead.
Didn't that have a longer lag?
No. It's the same. What I'm doing is I'm running it for a second. I want to see if this gets warm at all, but it's not. It seems okay. Let's make it do some work. That actually seems fine.
Is that water in there? Right in here?
It's called hydraulic fluid. It's a hydraulic system. All right, so what I'm going to do is I'm going to just see how these come on. See how these are slipping off really easy?
Which one are you going to use?
I'm just going to crimp, just give it a little bit of a... The only thing I don't like about these kinds is that they're strictly for cutting and stripping.
The front is for...
They don't have the little jaws on the front like my other... What I want to do is I want to be able to squeeze these down just the slightest bit. If I do it too much, then I won't be able to even get them on. You can actually see that it's spread apart. See how tight that is now?
Yeah.
And what we're going to do is we're going to put this in here and we're going to put the cover on so that if it explodes, it won't shower
There's
us
no
with...
gasket on
It
it?
doesn't look like it, huh?
Yes, there is.
Oh, yeah, okay. Oh, wow, what a cream
They
puff
di-
that
they
is.
didn't,
They didn't even shave the plastic off that was left over from the injection molding process. Not very... Well, you know, this thing wasn't super expensive. And I think I got it on a deal. I got some coupon or something. I got a really good deal on it. Let's
Freight.
get that crap out of there. Huh?
Harbor Freight.
No, this is Home Depot, I think. I bought this from. I went online and I looked around and actually found the best deal there. Excuse me. Grind them and find them. All right, let's go. What are you doing?
It wouldn't go.
What do you mean it wouldn't go? It just did. Why are you doing that? Why are you stopping and starting?
I'm pressing all the way.
Huh?
I'm pressing all the way.
So why is it stopping?
Oh.
Oh, you know what? Let me see if it's the operator. I wonder if all that surge in is what blew the capacitor. Strange operations. Let me try it. Let me see if it does that for me. You know what? It didn't do it for me. Let me try that one more time. Maybe
Because
I'm
you.
just, yeah. Well, let me check that out. Let me see if I can figure this out. I hold this lever down and I press this button.
Nope.
That damnedest thing. You want to try it one more time? See whether or not does it for you?
Nope.
Okay. All right. So what I'm trying to tell you not to do is don't do this. Okay. It's not your motorcycle that you're revving up to do a burnout or whatever. All right. Well, I guess we're going to call this video a wrap. All I got left to do is put that shroud back on, but nobody needs to watch us do that. I would say this thing is fixed, which you know what that means? Aiden?
Mark has to do work.
Well, you didn't finish your half yet. You remember you're doing half and he does half? All right.